everyone. Thanks for joining us today. Welcome to MadPow's webinar series. For those of you not familiar with us, we deliver research-inspired design aimed at improving the experiences people have with technology, organizations, and each other. But enough about us. The webinar, Maps, Diagrams, and Timelines, Inspiration for Interactive Design, is the 8th webinar in our monthly series. Today, Paul Kahn, one of our experienced design directors, will be sharing his insights on the subject. A little bit about Paul. Paul Kahn joined MadPow in 2012, following a decade as managing director of Kahn and Associates, which is an information architecture and interaction design consultancy in Paris, France. Paul's engagement with interactive design began in the 1990s when he co-founded Dynamic Diagrams with Christoph Lenk. Their maps and diagrams have appeared in Information Architects in '96, Understanding USA in 2000, Mapping Websites, and Atlas of Cyberspace in 2001. Just to let you guys know, too, a little bit of housekeeping. We will be live tweeting today. The hashtag is MadPow. There will be 15 minutes of Q&A at the very end. So if you want, put all of your questions, thoughts, anything you feel that is necessary in the chat and Q&A, which you can do privately to just myself and Paul or to everyone. The recording and slides will be available in a couple of days on our website, and we'll also make sure to send everyone in an email. With that, I hope you guys enjoy yourselves, and I turn it over to Paul. Thanks, guys.
Thank you very much, Courtney. So I don't really need to give myself much further of an introduction. I'd just like to explain that what I'm going to do today is share some maps and diagrams and timelines that I've used to find inspiration for user experience design challenges that I've faced and that I've faced with my teams. As a designer, I think of myself as a functionalist, and I like to remind myself often that user-centered design didn't begin and probably won't end with computer software, so there are many places to look for inspiration. So in terms of the goals for this presentation, I'd like to show you some examples, some of which are centuries old and some of which are much more recent inventions. But regardless of when they were created, the most effective designs are the ones that serve the user's needs. This idea that too much information, not enough space is a new idea is simply wrong. It's not a new problem. It's a problem that's several thousand years old, and there's some marvelous examples of how to solve it that go back quite a ways. There are many solutions that you'll find throughout the history of design, and it's an enormously fertile place to look. All of them illustrate ways we think about, we visually manipulate, we shape information to make designs attractive and effective on any form of display, be it a large monitor or a small mobile phone. The most important point here, I think, is one that I learned from my partner, Christoph Lenk, that what makes design work is in the user's mind. It's not on the screen, it's not on a piece of paper. It's actually what happens in the mind of the user when they see what you've done. So whenever you work, whether you're working on sides of walls, murals, painting airplanes, working on monitors or mobile phones, inspiration always can be found in the underlying principles of good design. So I'll start out with a nice academic question: what is a map? This first quote, which comes from Henri Abraham Chatelain, a map is an aid provided to the imagination through the eyes, is a very good point. Chatelain was a cartographer who created some of the first world atlases beginning in the 1700s. And his point that what you're doing is you're actually appealing to imagination, and that you're appealing to that imagination through the eyes is a very important point. Alfred Korzybski's famous quote, "The map is not the territory," is often used in contemporary philosophy, and it's had a lot of impact in a number of fields. But in the terms we're talking about today, you can think about it in its most literal sense that when you create a map, you're not reproducing the territory. Whatever the map represents is always some kind of a simplification, abstraction, or manipulation of the information that you're trying to present. And the last bit of fundamentals, this question, what is information? There are, of course, many different ways of answering that question, but the one that I find most useful and I think applies the most to visual design is this quote from Gregory Bateson. In fact, what's meant by information, the elementary unit of information, is a difference that makes a difference. And as we look at these maps and diagrams, I think you'll begin to see that they're made out of differences. Each difference in color, difference in shape, difference in spacing should carry information. That's where the information lies. So here's an example from Chatelin's work. This is a map of Canada or New France from the beginning of the 1700s. Some of the techniques that he uses here to appeal to your imagination, he's using color to make the areas appear as though they're European-style countries. This would appeal to the imagination of the users he has in mind. He uses this dark-light contrast to make what's most visible here the system of rivers and lakes, which was the main transportation network that was very important for understanding the space. And if you can see in some of the detail here, he's using icons, essentially, little illustrations that represent hills and trees to represent the concept of the countryside and the forests. So I'm going to start out by looking at some maps that visualize networks. This is a problem we often have when we're doing interaction design. I'm going to start out with two old examples, the Putinger table, the oldest one we've got, which goes back to the 3rd century, a Roman road chart, and the Romweg map, which was created by Erhard Hertzlaub in Germany around 1500, and then we'll go on to some examples of modern link node diagrams. So this is a contemporary map, and the green area with the various dots represents the region that is shown in the 3rd century chart called the Putinger table. So this was the Roman world around the 3rd century. The colored dots that you see here show the large number of locations that are recorded on this map, and the lines between them show the roads that were represented. So to represent the problem that the designer had here was they needed to represent this very large area with a very large number of points and lines connecting the points in a portable format. The table was probably used in a way that was carried from place to place, and it was actually physically 21 feet long and 1 foot wide so that it could be folded up. So in order to do that, they had to compress the space. And they compressed the space by essentially removing those things that are not important to the user. Water, for example. Since people don't walk across water, we don't need to waste a lot of space on water. And we also don't need to waste space on roads that aren't connected to one another. So they came up with this solution. It looks rather odd because the sense of north, south, and east, west is not what we're used to, but it turns out to be a very effective solution. Here's Canterbury over here on the coast of England. Here's Rennes, which is the capital of Brittany. And you'll notice that this dark area below Rennes seems like a narrow area. This is actually the coast of France. Toulouse, on the other side of the coast of France, is down here. And the Mediterranean, which is of no use to people who are traveling by foot, is compressed down to this little space here. And here's one of the towns on the coast of Algeria. So all of this was very user-centered. In addition, this map included icons that represented available services on the network. You see over here the little key on the icons. Different towns had different services, a place where you could have thermal baths, a place where you could get new horses. So they've abstracted this down. The distance between the locations on the same road, which is very important to the user, is recorded quite accurately. But they've removed all the space between cities that are not on the same road. What you see over here on the right, this large circle, is the city of Rome. And here's the Adriatic with Roman territories in Germany above and Sicily below, and then the North Africa coast over here. So they took this space and moved it into the smallest space possible in order to make it portable. You can see the icons a bit better here, so you could imagine someone using this could very effectively plan their trip and understand what kind of services they would get if they followed these red lines from one town to the next. So this technique is used quite often today. What you see here is the map that you would see inside the subway, at the Paris subway for Line 7. And Line 7, like many subways, has the feature that it has two places that it starts or ends at one end of the line. And the distance between those stations is of really no use to the person who's traveling. So here they've compressed it into the smallest space so that you can simply see where you're going, where you start from, and where you would change in order to get to one of these spots. If you try and represent it with the rest of the network, it takes much more space, as you see over here on the left. Or if you try and represent it with a street map and so forth, it becomes much more complicated and difficult to use if you're simply traveling on the network itself. The second example, the Romweg, was designed for a specific event. In the year 1500, as in the year 2000, many people decided that they wanted to go to Rome. It was a big pilgrimage year. And Erzlab was an instrument maker. He made different types of navigational instruments. He lived in Nuremberg, which is more or less the center of this map. And he made deals with the people that he sold his instruments to. He gave them the instruments, and they sent him back data on where they did their navigational calculations. And he seems to have amassed the most effective database of locations in Europe that was ever put together at that time. Since there was a large user population that wanted to travel from Northern Europe to Italy, he put together this map and printed it as one large broadside. What you see over here is a large hand-colored print. And it represents the road network connecting Northern Europe to Rome. Again, from a user-centered point of view, it's organized upside down by our current conventions. Since everyone that he's talking to is in Northern Europe, this is the foreground. So what you see on the bottom is the north. And everyone over on the bottom is going over there. Italy is at the very top. So the map is oriented from the North Sea in the foreground to the Mediterranean Sea at the top. This kind of orientation in its own way carries a lot of information, and is one of the things to keep in mind when you're working on something like this. He really pioneered one of the basic principles of linked node diagrams. What you see here is a close-up of Jutland and northern Germany. Down near the center, you can see the town of Lübeck and a set of dots connecting it to Hamburg, and then another set of dots connecting that to Bremen. If you actually count these dots and then you look at the distance that exists between these towns, you can see that the dots, which were, I guess, German miles at the time, are proportional to the distance. So someone reading this map could see the convention that an unfilled circle was a town, and they could count the number of dots between the town, and they could effectively predict how long it would take to get from one spot to the next. He was able to plot this against the information he had on the coastline and where the rivers were, and his representation of the position and distance between the towns is still remarkably accurate. So this idea of orientation can carry a lot of information. We saw in the Erzlab map that it was oriented from the North Sea looking out towards Italy. Here's some examples of graphics from the Cold War period. These are from Time magazine in 1952, and they're showing on the left, looking at Southeast Asia from Siberia across China, and on the right, looking from Moscow towards Western Europe. And this kind of an orientation clearly carried part of the message that the communist world was about to blow out and threaten the rest of the world. So how you orient things, how you position your point of view has a lot of value in these types of maps and diagrams. This is an example of some work that we did at Dynamic Diagrams in '99. We were presented with the problem of creating a map of all of the websites run by the Holtzbrink Publishing Organization. At the time, they had 150 websites, and we presented this as a linked node diagram where each of the nodes is a website, which is organized by the company that it was part of, but we needed some kind of an overall orientation, so we put the North American companies on the left, the Western European on the right, the Australia and South America and Africa on the bottom, the UK more or less in the center, and this gave some kind of a familiar way for the imagination of the user to read the map. The detail information was actually embedded in the nodes. So here you see individual screenshots, information about what language, what organization, what they were doing on the different sites. And in this case, the links between them, the lines, were navigational vectors. So they were indications that there was a link from one website that connected to the next. The idea of creating large linked node diagrams has grown as our ability to generate these from computer programs has grown. And this is a good example, I think. The InMap that is created by LinkedIn, this happens to be my set of LinkedIn connections. I'm not one of the most connected guys in the world, so you can imagine what a very connected person would look like with this kind of a map. This is what we would generally call a network cloud, right? So you've got an awful lot of points, you've got an awful lot of lines. The large number of lines as well as points gives this sense of you're looking at a cloud. The layout itself pulls nodes together, that is closer together, that have most connections, and the algorithm produces groups that it then represents with colors. So you see blue, you see orange, you see green, and these are generated by the algorithm. The emphasis on this kind of a system is on border conditions. So, if you point at someone over here near the edge, one of the reasons that point is prominent is it seems to connect several places. The other thing that it makes prominent is someone who has a lot of connections. So if you see a large circle, you can point at that circle and highlights it. But the overall utility to this is an interesting question, how much this kind of exploration really gives value for understanding how things are connected. The same kind of linked node diagrams are often used in newspaper graphics. This is an example from 2004. It's talking about a presidential campaign, but it could be talking about just about any presidential campaign. And here the designer is using basically two types of nodes. These large green nodes represent either businesses or other type of focus that are related to the person in the center, family or businesses. And then the individual icons represent either people who are appointed to the government or not appointed to the government, all of whom had given money to the campaign. Again, with this type of a linked node diagram, one of the things that happens is that if someone has a number of lines crossing on them, they seem to become more prominent. Here's Karl Rove over here. He seems to be more connected than some other people. But one of the downsides of this kind of a diagram is that the distance between the points, that length of the line, actually contains no information at all. It's simply an artifact of the layout. So the fact that this person seems to have a very long line and this has a short line is a difference that actually doesn't make a difference and downgrades the quality of the information in the diagram. These types of linked node diagrams can be used for real simple interactions. This is a new product that launched recently, Visify, which is a website for creating visual biographies. Here, the points, the nodes themselves represent types of information, and the lines that connect them are actually rather arbitrary. But they do give an interesting feel and an interesting kind of interaction. What you need to be careful of, though, is connecting too many things. This is a slide that became famous about 2 years ago, it was presented to the Joint Chiefs of Staff in NATO as an explanation of what was going on in the Afghan war at that time, and General McChrystal, who was in charge, was quoted as saying, "When we understand that slide, we'll have won the war." And apparently neither of those two things have happened. The main point to get from looking at an example like this is try to avoid connecting everything to everything. The more lines you add to a diagram like this, the less comprehension you're going to get from the people who are trying to understand what the connections between the nodes mean. So another historical example that's been a great inspiration to myself and many others is the Turgot Map. And this is an example of how to deform space to present information better. Might seem counterintuitive, but sometimes deforming or changing the space will make the information come across much more clearly. The Turgot Map wasn't made by a man named Turgot. Turgot was the governor of Paris who commissioned it. It was made by two engravers, Berthez and Lucas, in the early part of the 1700s. It is a map that represents all of the buildings in the city of Paris at that time. Turgot gave them the right to visit and survey every building in the city, which they did over a period of about 13 months, and then did drawings to scale of every building in terms of how many windows it had, how many floors it had, where it was on the street. In order to make all that information fit, they created an isometric projection of the streets and the architecture with a single vertical scale. Isometric projection is something that's used in architectural drawings. It literally means that all of the lines are parallel. There is no vanishing point. And for information design, one of the most useful aspects of this kind of a projection is that everything at the bottom of the map is at exactly the same size as everything at the top of the map. Things don't disappear off into the distance and get small. Some of the deformities that they went through was in order to make the streets visible and the labels for the streets visible, they widened all of the streets to expose areas to put the street names. And they also flattened the city. Paris is not a very hilly city, but it does have some hills. And if they had represented the hills, it would have obscured some of the buildings, so they simply flattened things. Interestingly enough, they created two separate scales, which we'll see in a moment, one for everything actually on the land in the city and another for the river. So what you're looking at over here on the right-hand side of the screen is the overall map. It was divided up into 16 sections, and each section was a plate. What we see over here on the left, this two-page spread, is one of the plates. And here's some of the detail. Some of the technique that they're using here is you'll see that all of the buildings rise up as though you were looking down at about a 30-degree angle. This is commonly known as a bird's eye view now. It was calculated fairly precisely, and it allowed for a maximum of exposure for the sides of the building, so you could get a sense of the architecture without being too high-pitched, so that you didn't get a sense of the height. You'll notice here some of the details of how they show some holes in the ground and some things rising up, but nothing goes very high, or nothing goes too low. And there's quite a bit of distance on these streets, so that they could easily place the names of the streets down on the paper plane. What was interesting to me, because it actually eluded me for several years as I was working on this, is that they managed to do this and create actually two scales of size. Part of what they were trying to do in this map was show how orderly and rich Paris is. So one of the ways they did that was by having no people on the streets. There's absolutely no one in a city. But at the same time, Paris was a major port, and they wanted to show off the fact that there was lots of activity on the port. So you'll see here on the Seine that there are a lot of boats, and there's a lot of warehouses and yards where different types of materials are piled up to load onto the boats. As you look at this, there isn't immediately a sense of how different things are, but in fact the scale on the river is a completely different scale than the scale on the land, and you can see it a bit better in this shot. So here's a detail of Ile-la-Cité, where Notre Dame is. If you look at the boats in the river down here, there's actually someone standing in one of those boats. If you place that boat next to one of the buildings, you'd see that that person is about 3 stories tall, and the boat is actually bigger than the building. But it's a good example of how you can create separate scales for different types of information if you understand the way people are thinking. People simply could easily separate the scale on the river from the scale in the town as long as they didn't get too close to one another, they weren't mixed. So how effective is this kind of a map? Turns out it's really quite effective. This one's quite literal, and much of the city hasn't changed dramatically. This is where my office was for a long time, near the Temple District. That's where the temple used to be over on the left. This is where my office is, looking at it with Bing bird's eye view. And this also gives you a much clearer sense of what happens when you don't do these types of deformations or distortions in order to create this bird's eye view and overlay the grid of the streets. They've had to place the grid of streets as though it's floating on top of the buildings, since literally there isn't enough room between the buildings to show where the streets are. So when we were doing different types of maps of large websites or other types of networks, we often made reference to some of the techniques that we learned from the Turgot Map. This is a map of the Nature website from around from 1999. And it illustrates several of the techniques that we learned from this. One is it's an isometric diagram. This allows you to overlap certain elements and compress the space. At the same time, it uses 2 different scales, one at the paper plane and the other in this isometric projection. One to show flow, as you see over here, the other to show some other types of relationships. Some of the most useful things about this type of a design is that when you place things on a grid or on a carpet, the Gestalt Principle brings these individual elements into a cohesive whole. And so you can quickly see that all of those elements on the orange carpet, all of those elements on the green carpet are together without having to create a lot more lines connecting things. The alignment and the grouping of the items links the items without the need for a lot of additional vectors or lines. And the groups are established primarily by color and by proximity to one another on the grid. It can make for a very dense diagram that is relatively easy to read. Transportation networks is also an area that we can get a lot of inspiration from. There's plenty of discussion as to whether we would want to call these maps or diagrams, and I have no particular opinion on that, but it's a good thing to think about. And the great inspiration here is an invention by Harry Beck, who was working for the London Underground in the 30s. His redesign of the Underground map really pioneered the types of visual systems that we have today, and many of the techniques that he uses here can be reused in a lot of different contexts. So some of the things that you'll see in the evolution of examples that I'll show here are the disappearance in these types of transportation network diagrams of above-ground details, kind of abstraction or removing of literal details. The stretching and compressing of the space to improve the legibility of the diagram itself, and distorting, in this case, the geographical information, not just to widen the streets, but to have it fit to a regular grid. So I'll start with a counterexample. This is a map of the first New York subway system from 1905. And it contains a number of details that completely disappear within the first generation of doing these types of diagrams. One of the things that you'll notice in the center here is that Manhattan is shown with the south on the left and the north on the right. That was simply a better way to fit it onto the piece of paper, since at that time that was the extent of the system in New York. But you'll also notice how complicated and dense that map is. It's because in this map they've represented every single city street, and they've labeled every city street. This is a detail that certainly disappears as the evolution of these types of maps and diagrams goes along. Another really interesting detail is right down at the bottom. This is something that shows up in some of the very early subway maps and disappears fast. You'll see a profile map down there with a little white line going through it. This was a map, this was a diagram that showed you how far underground you are when you're traveling on the subway. We think about this from user-centered and user satisfaction. Anyone who's done a survey on this will discover that people who are riding subways do not want to know how far underground they are. The engineers who developed this were very proud, and rightfully proud, of the fact that they'd done it, but in terms of useful information to the traveler, this is a detail that disappeared quickly. So here's the London Underground map from 1920. This is leading up to what Beck did. And it has a number of techniques that we still use today. One is this use of color to separate the lines. Understanding how useful and important this is really takes looking towards the center here and realizing that we've got 5 or 6 different lines crossing, and if we did not have the color code, it would be extremely difficult to follow the line. It would be difficult to notice which of these lines that are crossing is continuing in which direction. But with the color contrast, the eye can very quickly pick out the green line, can pick out the orange line, can pick out the blue line, and so forth. This map is using realistic distances between the stations and also realistic curves to represent how the lines were moving. So we see this jumble of lines moving at rather irregular curves, all moving across a landscape. And if you look down on the bottom center, you'll see how much distance there is between those stations on the green line. That's because there's a lot of distance between the stations on the green line. But you'll also notice that it takes up a lot of space on the map. So Beck was presented with a challenge. He was part of a competition. The idea was to create a diagram that would represent the entire network, which had gotten larger by the 1930s, and also could be folded up on a single piece of paper and placed in your breast pocket. So it required a lot of compression. So Beck did a number of things to create this diagram, and it really was identifiably an invention. He was an electrical engineer. You might suspect that this looks a bit like an electrical wiring diagram, and I'm sure he had that in mind. But the principles that he followed are really good visual design principles. One is that he aligned every one of the lines that you see here on a grid, and every line is either at a 90-degree angle or a 45-degree angle. Just how unnatural that is, it's easiest to see when you look at the River Thames down on the bottom. I guarantee you the River Thames does not run at 45-degree angles, but to fit into Beck's diagram, it did. And that was fine because from the point of view of a traveler, all you wanted to know was which side of the Thames you were on. You're not navigating a ferry here, you're navigating the subway. The next thing that he did was that he increased the distance between the stations in the center of the city, and he greatly decreased the stations in the outlying areas. This made it possible to add the names of the stations clearly. And he introduced this code that you see here, where the places where there are changes, where you change from one line to another, is represented with diamonds, and in other places by lines where there is no change. So I'd like to go over to a wonderful animation that was made in 2000 for the London Transport Museum to really illustrate how this type of a design works. This is close-up of the original 1933 map, showing you how the lines were set up at that time. Here's what the same lines look like in 2004. And one of the interesting things that happened is they added lines to create this kind of a pattern. Some of you may notice or have already known the central part here, that yellow circle line, takes on a milk bottle shape. And that milk bottle shape is not literal, but as they evolved the design, it became an easy to understand mnemonic for that circular pattern in the center of the city. To understand just how far away this is from the way London's actually laid out, this is the actual layout of the lines. And if we were to add the street map, you can see just how complex that is. Complex to follow if you're moving through it, and also complex to grasp if you're looking at it quickly. So it's this kind of a simplification for the transportation network that really was Beck's legacy, and it's still with us today and something we can all learn from. Some examples of how this works out in other contexts. This is the interstate highway system in the United States, literally. This is a layout of the highway system on realistic geography of the United States. Again, if it was large enough and if you had enough time to move around in it, it might be good, but you can see that there's enormous differences in distance between the lines and very difficult to see how the roads actually connect. This is an interesting simplification of it done by Chris Yates some years ago, which really is using almost exactly the same technique that was used in the Puttinger map. So he's straightened out Interstate 95 over here on the right. You can see if you were driving from Portland, Maine down to Miami, all of the cities that you'd be traveling through. You can also easily see the connections for Interstate 80 going from New York to San Francisco and so forth. But the actual distance between the points in this map is totally unrealistic. So he's changed the distance between the points in order to make the map easier to read. And then more recently, Cameron Booth, a cartographer in Australia, did this really interesting map. And this, in some ways, combines both the principles in the Puttinger table and in Beck's map. So he's using color here to clearly separate some of the major highways. And he's deformed the actual size and proportions of the United States outline to make the highway system a little easier to follow, and kept everything at this 45, 90-degree grid to create a visual rhythm that's much easier to look at. So let me show you a couple of examples of metaphor maps, because metaphor, which we've already seen in some of these examples, is also one of the most powerful areas to think of when you're trying to do visual communication. These first two examples are, one is a French and the other is a German map from exactly the same year that represent Europe in terms of national stereotypes. And they're good examples of using a map not as geographical information so much, but as a metaphor for containing ideas. This was Europe from the French perspective in 1870. And you know, if you look at this and it looks like Europe to you, it's because in your mind you have this geographical outline that the artist here has filled with caricatures of different types of national stereotypes. Here's exactly the same part of the world from the German point of view in the same year. Over here, Russia looks like it's a little hungry, heading towards Western Europe. Over here, it looks like it's definitely about to swallow Turkey, right? But all of this is done with the same kind of metaphor in mind. In this case, the outline, placing figures into the outline. A really interesting and very extreme case of metaphor, map, or diagram is the work of Fritz Kahn, who was a physician and science writer in Germany in the 1920s and on into the 50s, I guess. But his most famous work, several volume book on the human body. Was titled Man as an Industrial Palace. And it's a really great example of using the human body as a diagram, and introduces a technique that we see in a lot of diagrams. This little man, or homunculus, gets added as an actor or vector in order to suggest that things are happening. And in this case, he's explaining a biological process through mechanical metaphor. So this is a bit from the poster that comes with the book, an explanation of what goes on in your brain. And the person in this case is about to eat a piece of chocolate. We've got this remarkable video that was created by a graphic design student in Germany a couple of years ago, which had some nice sound effects to it. And he's literally taken the illustrations, the poster, and he's animated it. This is by Henning Lederer. Here's our little man up here firing off the saliva gun. What's really interesting about what Kahn did in the original design, and what Lederer is doing so marvelously in the animation here, is that he's using a set of mechanical principles that he presumes his audience understands as a way of metaphorically explaining a set of biological principles that they've never seen. And so this technique can certainly be used in a lot of ways to explain different types of processes. The last thing I wanted to introduce were some examples of timelines. Again, the timeline turns out to be something that was invented. Joseph Priestley in the late 1700s invented the timeline, both the historical timeline, aligning cultures and categories with chronology, and the biographical timeline, the whole idea of creating alignments of lifespan and chronology. And I'll show you a couple of other examples, 20th century examples from Alfred Bar and art history, and the work of the great designer Herbert Bayer. So what Priestley did in inventing the timeline was to come up with a way of taking an enormous amount of information, placing it into a single diagram that could be read both from left to right and top to bottom. Here he's using an alignment principle that the vertical is geographical or cultural units, and the timeline, the chronology itself, is the horizontal. If we look at it a little closer, we can see that he's chosen a set of European sense cultures, Spain, France, Italy, culture regions, and then going back through time, he's representing the different empires or cultures that were in these territories over time. So as we look at this from left to right, we see that the Roman Empire covered a certain amount of space, here separated by the use of the color green, and that the Ottoman Empire, called Turks over here on the right, covers some of the same space, so we can sort of look at it backwards and forwards as well as top to bottom. And this type of an alignment diagram as a timeline shows up in many different contexts. He also pioneered the idea of a biographical timeline, representing a person as a line, showing the lifespan, and then aligning these lines against the single chronology to essentially expose which of these people were contemporary with one another. In this case, he's displaying the lifespan of different classical Greek authors. So that type of a system can be combined with kind of linked node vector. What you see over here on the left is a famous diagram done by Alfred Bar, the man who was the first curator at the Museum of Modern Art in New York, explaining modern art in terms of movements with the vectors showing influence between artists and movements. And in this case, from top to bottom, the chronology is the vertical rather than the horizontal here. And the example on the right is someone's attempt to continue that to show something more about contemporary art. It becomes a bit more of an example of having too many lines connecting too many things. But it's used in many different contexts. This is the wall in the Tate Modern in London. I don't know if this installation is still here, but a few years ago someone created an enormous timeline of art using size and type, in the sense that some of this is, the separation here is whether it's in cursive or in or printed, and how big it is to separate the different layers of information, all of which are aligned to the chronology. And I'd like to present this one as what I think of as one of the best examples of the type of design that I'm talking to you about today. This is a single diagram done by Herbert Bayer, who was one of the Bauhaus artists from Germany who came to work in the United States after the Second World War. This was done for an atlas that he designed and produced for Container Corporation of America. What you see over here from left to right is the succession of life, sort of biological evolution of life, geological evolution, mountain building in the center, and the time period on the right, in order to represent these enormous periods of time from the beginning of Earth to the present. He takes time and turns it into a spiral on the right so it doesn't take up too much space, and then as time catches up with the evolution of life, it hits the grid and continues up, so that we continue up through the different evolution of species up to the creation of man. And he's combined both the sense of spiral as a metaphor for time, as well as the sense of flow that we have here, so that the size of the line getting wider and smaller also represents some information about the fluorescence of reptiles here and the falling off of reptiles and the beginning of mammals and so forth. All of this actually fits into a single part of the page. So there's an enormous amount to be learned in terms of compressing information into small spaces, such as the screen of an iPhone, from these types of graphic designs. I'm going to finish then with this very contemporary example. This is an example from the really great information design group at the New York Times. So I'm going to run this, and then I'll give you some commentary on it. This is from the recent Olympics. And the voice, I believe, is Jada Boomrod.
Nathan Adrian's 100-meter freestyle was fast, one of the fastest in Olympic history. But how fast is that? What if he were swimming not just against the other swimmers in London, but against every Olympic medalist ever in 100-meter freestyle? Here, we're gliding over 116 years of Olympic history. This enormous historical pool contains some of swimming's biggest names, from Ian Thorpe to Mark Spitz to Johnny Weissmuller. And it takes us all the way back to Athens in 1896, when a Hungarian named Alfred Bar won in 1:22. Here we've placed him in a modern pool, but he actually swam in the cold waters of the Mediterranean Sea with hollowed-out pumpkins for lane markers. Seriously. Back then, Bar was one of the fastest swimmers in the world. But in a modern down and back race, when today's winner is wrapping up, Alfred's more than 42 meters back, just over halfway done. In 1924, Johnny Weissmuller was the first swimmer to break a minute. 4 years later, he won again. But in this pool, they're still 20 meters back. Why are these early athletes so far behind? It's partly because of advances in technology and training, many of which came about during the Cold War. Starting in 1956, Swimmers set records in 8 of the next 9 Olympics. The 55-second barrier fell in Tokyo in '64. 12 years later, James Montgomery swam it in less than 50. And today's athletes are right around 47 seconds. They're chipping away at that next barrier, the 45-second mark that seems impossible. But is it? Here's one way to think about it. Since the 1950s, these Olympians have gotten about 1 second faster every 8 years. If they continue at that rate, man, that's a big if. A 45-second finish might happen in about 12 or 16 years, say the Games of 2024. Obviously, it's impossible to know. But if that barrier is ever broken, today's athletes would be about 5 meters back. No longer the best ever, just the best of their time.
So I offer this to you as a really marvelous piece of interaction design animation, but just to tie it back to some of the examples, here they've made a really great leap in the use of metaphor. They've taken an Olympic pool and they've metaphorically turned it into an inverted data grid. Obviously, the audience is very much in mind here, since they know the audience will immediately recognize the association between the information and the pool. They've used alignment to take the swimmer's horizontal position across the pool as the year of the race, and their vertical position as the time converted into distance from the fastest finish. And that information, that basic grid, can then be used to spotlight individual swimmers in a lane by year, as you saw, and also to allow these time barriers to appear as horizontal lines at 1 minute, at 48 seconds, and so forth. So they've taken all of these principles and turned it into something that is very important in data journalism. They've turned it into a story. I think it's really a terrific example of the kind of inspiration you can get from a diverse number of examples and techniques. So with that, I'll end the talk, and I'd be very happy to have any comments or questions. I'll take a look at what you've been typing and see if I can provide any feedback to you. Look forward to seeing what you have to say.
Just a reminder to everyone too, when you want to post a question, you can put it in the Q&A box or you can put it in the chat. We definitely welcome all questions and comments, and there is no question that is too small or too long. I actually kind of have a question. Is there typically, like, I don't know, with kind of like the transition from, you know, taking these inspirations of the maps and kind of looking at even like the streets of Paris to like what you just showed us with, you know, the Olympics, like, do you think there's, like, what kind of, like, correlation in the sense of design? Like, is it the whole, like, actual map layout, or is it, like, I mean, what part of that do you think, you know, taking these two abstract kind of images and ideas that make it so inspirational and, you know, make it so relevant to, let's say, designing a wireframe for some kind of internal communication guidance tool?
Well, I think that the main lesson that you can learn from any or all of these is recognizing what will be most effective in communicating to the audience. You know, I think one of the great strengths of the kind of work that we do is that the ideas of user-centered design have evolved over the past few years to include a lot of analysis, interviews, talking with people, trying to understand how they think. And what makes each and every one of these designs work is that there's a very direct relationship between the type of information that the designer is trying to communicate and the way the audience thinks. What makes them effective and what makes them fascinating is the choices the designer makes in order to make that connection between what is in the user's imagination and the kind of information that they want to get across. Often the trick is to do that as cleanly and simply as possible, so that the user doesn't spend too much time being fascinated by what a great designer you are, and gets the information that they're looking for. So I've got a question here. Can you talk about the balance of when the display of maps and timeline data becomes not only informational but artwork in and of itself? I think that one of the questions I always ask myself when I look at this type of work when we're doing it for websites or for applications is how useful is the process of exploring or recognizing information in maps or timelines versus just the fascination of making maps and timelines. So I think that's where the balance has to lie. There is a lot of information that when you place it in a timeline or in a map becomes easy or more interesting to explore. And so, if exploration is one of the main purposes of the project that you're working on, it's a very, very useful road to go. But if simply finding something or locating something is as important or more important, placing things in lists or placing them in other types of easier to sort through combinations might be just as effective or more effective. Got a question. I think everything presented was read-only. All the examples I gave you are read-only. Informative but not interactive. Does the map idea break down once you're using it to convey feedback in an interactive setting? The act of selecting a subset, choosing some swimmers from the pool. I think that the answer is it can be enormously effective as an interactive tool. I didn't use too many examples of interactive tools here, mostly to simplify the presentation, but even the LinkedIn map is probably the most concrete example that I used. That as a tool is really only effective as an interaction. You're given this pattern, but other than seeing that you've got a nice colorful cloud, if you actually want to see where people are in this relationship and how they're connected, that's done entirely by interaction. And I think in general, answer to your question, if you're designing for a single narrative, as the people in data journalism generally are, then you want to be able to tell that story well, quickly, get it out there, get it done, and leave something in people's memory. If you want to be able to create a wonderful exploration space that will allow people to find the kind of information that they want, then you've got a different kind of theater and dynamics that's going on in the interface. Question, how can we effectively compress data visualization for phone screens? At a certain point, the information gets too small. The simplest answer to that is you do it by figuring out absolutely what is the most essential information that you have to present, and then scale it appropriately. A good example for presenting information on phone screens, I don't have in the slides here, but you should be able to find it easily enough. There's a good application for the bike share system here in the United States. Actually, I can find it. Hold on a minute. Which one is it? It's called Sports Cycle. So if you go to the App Store and look for Sports Cycle, Sports Cycle, I think, has one of the best displays for the information problem. Where is the nearest bicycle station? How many bikes are at that station, and how many parking spaces are at that station? Those are the three questions that application is trying to answer for you. And they have a very small amount of space, right? It's an iPhone application, and they managed to do that by using color very effectively, overlaid on a realistic but quite abstract map, and then the size of the colored dot and the transparency of the colored dot gives you the other pieces of information, how many bikes there are and how much space there is for parking your bike. So I think that's a really good example. One last question. Are there any contemporary maps or diagrams that I feel are really compelling? Well, I tried to put most of them into the presentation today, but it's a short presentation, so there are certainly others that I use when I'm teaching, and others that you'll find in some of the other presentations that I've done. I just tried to focus on what I could get across here in 45 minutes.
All right, well, that kind of concludes everything. It's 2 o'clock, and to kind of respect everyone's time, I'm sure you all have to get going. We thank everyone for coming. We'll be having yet another webinar here shortly in another month, and we'll keep you posted on that. Paul, thank you. You did an awesome job. And just as a reminder, we will have the recording and the slides available on the site in about a day or so. We'll also be emailing everyone, so if you're having a little bit of technical difficulty, don't worry, you will get everything. And we appreciate everyone's patience and time today. Thanks, guys.